Hi guys, so this is Vicky again, and we are continuing with the 2015 AP Chem FRQ questions, and this is question number 3. So question number 3 says, potassium sorbate, and they give you the molar mass, is commonly added to a diet soft drink as a preservative. A stock solution of this, of known concentration, must be prepared. A student titrates 45 milliliters of the stock solution with 1.25 molarity HCl using both an indicator and a pH meter. The value of Ka for sorbic acid is that much. Write the net ionic equation for that. So the net ionic equation is going to be, obviously, what are we creating? So it's this and this. These are going to be the reactants, right? So I know that, okay, first of all, let's look at who is the spectator ion. Who are the spectator ions? Remember spectator ions from our solubility rule and the first column of the periodic table, the Lena column, super slutty, so she's never in a solid relationship, so she's always going to be a spectator at a wedding. Okay, so that happens to be part of the Lena column, right? And obviously if K plus is a spectator, Cl minus has to be a spectator because opposites attract, right? So I end up with C6H7O2 minus plus H plus, and if I put these all together, I end up with C6H7O2H, okay? And that is my sorbic acid. So I have my sorbic acid, and that's the net ionic equation. And let's continue with B. It says a total of, weak acids. Every time we have weak acids, we don't ever want to use a direct arrow. Weak acids, they go back and forth. And if you guys remember from my previous videos in regards to the nature of weak acid and bases, they go back and forth because they're so weak they can never be single by themselves, right? Okay, so they don't dissociate 100%. So we always use this double arrow. All right, B. A total of 29.95 milliliters of 1.25 molarity HCl is required to reach the equivalence point. Calculate the concentration in the stock solution. So let's start out with trying to understand what equivalence point means. Equivalence point means that I have the same number of acids to bases, right? So if I start out with 1.25 molarity of HCl, I need to figure out the moles of HCl so that is the exact same number of moles of the base that I have, right? So if you guys remember M times V, right? Side note, M times V, molarity times volume, it's always going to give you moles. If you remember this, you can actually do this question really easily. So molarity, I am just going to multiply this out by the volume, and the volume has to be in liters. So it's 0.02995 liters, and I end up with 0.0374 moles of HCl. If I have moles of HCl, and I know it's a 1-to-1 ratio because if you look up here in this equation, it's a 1-to-1 ratio, I know that I'm going to have the same number of moles of sorbic acid, right, or sorbitate. So it's 0.0374 moles of C6H7O2 minus, okay, and that is the number of moles, and I want to multiply this out by the volume, right? Divide it out by the volume because I need to figure out its molarity because we're looking at concentration. So what is the total volume when we reach equilibrium? They tell us up here that it's 45 milliliters, right? So that's going to be 45 millimeters, 0.045 liters, and I end up with 0.832 molarity of C6H7O2 minus, and that is my concentration. Okay, all right, so now let's continue to C. And what is C? It says the pH at the equivalence point of the titration is measured to be 2.54. So pH is 2.54, all right? And which of the following indicators will be best choice for determining the endpoint of the titration? So if you guys remember, okay, if this is the titration curve and that is my equivalence point, the indicator has to be able to encompass a plus or minus 1 pH value. Okay, so we're looking at something that is going to encompass that plus or minus 1. So that looks like it's going to be diamol blue. So the answer is diamol blue because it's plus or minus 1 pH. Okay, all right, let's look at the last question. So calculate pH at the half equivalence point. Half equivalence point is basically if that point is my equivalence point, right? Okay, I am looking at half of that. So the half of that is right here. And half of that basically says that the moles of conjugate base has to equal the moles of its acid. Okay, so if you guys remember the Henderson-Hasselbalch equation, pH is equal to pKa plus log of conjugate base over acid, right? But if A minus equals HA concentration, all this ends up being 1, which means this whole equation over here will end up being 0. So at the end of the day, pH equals pKa, right? And they have given us the Ka value. And what is P? It stands for negative log of Ka, whatever comes afterwards, right? So it's negative log of, what is the Ka value? They tell us right here at the very top, it's 1.7 times 10 to the negative 5. So I'm going to plug in 1.7 times 10 to the negative 5, and I end up with 4.77, and that is going to be my pH. And that's it, and I will see you guys in the next video. Bye!